All right, solving inequalities. I think we've seen this slide before. Just remember, we're using principles of equality. Whatever you do to one side, you got to do the other side, just with one exception. If you ever use multiplication or division principles of equality with a negative, meaning you divide both sides by a negative, multiply both sides by a negative, you have to flip the inequality because the negatives are opposites. So when solving compound inequality, it may be helpful to split the inequality into two separate inequalities. We probably won't. By compound inequality, I'm talking about full compounds like these types. You can separate those into two, which we've seen. If it's an or and statement, then they'll already be separated into two inequalities that you'll have to solve. And since we love these so much, it's twice the fun. This one actually is not too bad because it's done. I don't actually have to do any principles of equality to solve this, right? So I'll do this one. I'll do the first one in red. Let's get some numbers on the number line, though. So we got 0, 6, and 12. So at 6, that's x is less than 6, so that's an open circle. It's not eating the x, so it goes to the left. And then I'll do this one in purple. That's a 12, but it could be equal to 12. So I got a closed circle of 12. This one is eating the x, so it goes to the right. If for some reason we had an and statement between those two, there wouldn't be any solutions because the two lines never intersect, which we saw in the one example. But for the or statement, I know this goes to negative infinity. It stops at 6, which is not included, so it's a parentheses. I'll unite these two starting at 12, which is included, so it's a square bracket, and it goes to infinity, which is never included, so there's a parentheses. This is the interval that we want. For this or statement, we do need this graph, though. And then, yeah, it's already solved the inequality for us, so that's pretty good.